Hey everyone, this is John, and in this video I'm going to be talking about a touchless paper towel dispenser from the book Programmable Microcontrollers with Applications Using the MSP430 Launchpad by Mr. Unsalan and Gurhan. So, what's going on here is that there's a light-dependent resistor here, and whenever I wave my hand over it, it detects the lack of light, sends a signal to the microcontroller sends a signal to the motor controller turns on, spins one direction, stops, then spins in the other direction. That's basically what happens. Now let's get into a little bit more deeper understanding of what is actually going on. So light-dependent resistor. The darker it gets, the greater the resistance. The greater the resistance, the greater the voltage drop over the resistor. The microcontroller is checking the voltage level of this resistor, and when it hits a certain threshold, it sends a signal to the L293D motor controller. Now this motor controller takes that signal and sends other signals to the motor, driving it to spin in one direction, to stop, and then spin in the other direction. Now, why do we need this motor controller? Why do we have the L293D there? Why can't we just use it? Why can't we just control the motor from the microcontroller like we do the LED and the resistor? We need that motor driver for two reasons. The first reason, motors need a lot of voltage and a lot of current. Sometimes more voltage and current than a microcontroller can provide. And so that's why we need this motor controller, because it can handle the amount of voltage and the amount of current that DC motors and motors in general and other equipment need. So that's the first reason. It can handle the voltage and current. The second reason is that inside it has very fast switches. These very fast switches that can handle large amounts of voltage and current. And the reason that we need these very fast switches is because we're controlling the motor using pulse width modulation. Now, what is pulse width modulation? Basically, pulse width modulation is you take a segment of time, we'll say 1 second, and you break that second up into 1,000 chunks. So we have 1,000 chunks in 1 second. And for 50% of that segment, that chunk, the motor is on. And the other 50%, you turn the motor off. So the motor is only on for 50% of that chunk, and there's 1,000 chunks in that second, and then however long the seconds run. So you need a switch to be able to turn the motor on and off each chunk, and there's 1,000 chunks in a second. So you need a switch that needs to be able to switch on and off 2,000 times in a second. And that's why we need really fast switches that can handle high current and high voltage. And that's why we need this L293D or a motor driver. Now you might ask yourself, well, why do we want to switch the motor on and off so often? Why don't we just give it voltage and current like we do an LED and just let it go? Well, we want to switch the motor on and off because the motor will only be on for 50% of that chunk. So if it's only on for 50% of the time, it's only using 50% of the power, which is really great if you're running off of a 9-volt battery, because the battery lasts twice as long. It's really great because you're only spending half as much money on power to drive the motor than you normally would. That's why we're using pulse width modulation, to be able to drive the motor at less than 100% power and save power. So that's basically why we need this L293 motor driver. Now, some other components on the board to talk about. This potentiometer. This potentiometer controls the sensitivity of this light-dependent resistor. So, if I turn the potentiometer one way, you'll see I have to pretty much cover the resistor to get the motor to move. I turn the potentiometer another way, it becomes much more sensitive. So that's what that potentiometer does. It controls the sensitivity of the resistor. Now, another aspect is this stuff over here. What this stuff does is it takes the power from the 9 volt, and this is a LM317 voltage regulator, and it takes the 9 volt power and it regulates it down using this potentiometer and this resistor and capacitor to 3.5 volts, which is what the microcontroller likes. So this LM317 takes 9 volts, regulates it down to 3.5, what the microcontroller likes. Now right here is essential if you want to use this microcontroller, the MSP430 G2553 on a breadboard. You need this 47 kilo ohm resistor, and it needs to go from 3.5 volts from high voltage to the reset pin of the microcontroller. You just need to have that there, because without that resistor, without that voltage input to that reset pin, the microcontroller will just not work. So you absolutely need that. And I've connected that to a reset button. So if ever, something's going wrong with the application, I have that. I just hit the reset button and it resets the software. So that's the reset button. This is the voltage regulator. This is the sensitivity adjustment potentiometer. This is our motor. This is our motor controller chip we need for 2 reasons. 1, for high current and voltage, and 2, for pulse width modulation control. And this is our MSP430 G2553 microcontroller chip that controlled everything. That was a video. I'm John. Hope you liked it. If you have any questions, leave them in the comments and I'll do the best I can. Have a good one.